Hello everyone, welcome back to our college algebra course. For this week lectures, I'm gonna talk about the first section of chapter 5, section 5.1. It is about polynomial. Okay. So 5.1, polynomials. Okay, so what is polynomial? I claim that actually we have seen polynomial before, we just call them with different names. So let's look at it. Say f of x equal to 2x plus 3. You guys recognize this because it's a linear function, right? Where the graph is a line, slope, and y-intercept. For this one, f of x equal to 3x squared minus 7x plus 1. This is what we call quadratic function. This is linear function. This is quadratic function. Okay? And we get the idea of this type of function. The structure of this function is what? A number times x to some power, then plus or minus a number times x with some power, and the exponent, the power keep going down. Okay? And in general, those kind of functions, we call them the polynomial. And of course, we can have a bigger polynomial function, as you can see. We change the marker. Negative 5x cubed plus 2x squared minus x plus 1. Okay. Bigger, right? This is just a single x. This is x squared. Now we get to the third power. Actually, we have a name for it. It's called cubic. All right. Even higher is f of x equal to 7x to the fifth plus x to the 4 minus 5x cubed. I'm just making up. Plus 3x squared plus x minus 2. This is another polynomial function. So with those kind of small exponent function, we have learned it entirely. It's linear function, quadratic function, and later on you may learn about cubic function. And in general, those kind of functions we're going to call them the polynomial function. Okay? And by the way, the highest exponent right here, because the degree of the polynomial. So this one, the linear function, is a polynomial of degree 1. Quadratic function, as we learned before, is a polynomial of degree 2. Cubic is degree 3, and this one is a degree 5 polynomial. Okay? And those numbers, by the way, we're going to call them the coefficient. And a number in front of the highest degree term, we call it the leading coefficients. Okay? So those are examples of polynomials. So just number times x with some power, and plus now number times x with some power all the way to the end. So let me give you a formal definition of polynomial function. Number 1, definition. A polynomial or polynomial function is a function of the form f of x equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus da 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 all the way to say a2 x squared, a1 x, a0. Okay? Since I don't know how many terms I'm going to have in the polynomial, we have to write this way, where xn minus 1, n minus 2 all the way to the n is what the variable x with the exponent, right? And then the an minus 1 all the way to a0 is other coefficient. And this n right here called the index, right? Just counting the terms. Let's box that. So basically the definition say what? If you have a function looks like this, a number times x raised to some powers of whole number plus a number times x raised to some power, keep going that way all the way to the end, we're going to call it a polynomial function. And again, I have to explain the term. N is called the degree of the polynomial. Okay. A0, A1, A2, A3, all the way to AN is called the coefficient. Okay. The term AN right here is the leading coefficient. And we do have a condition for AN. AN needs to be non-zero. Because if AN is 0, then the degree of polynomial is gonna go down by 1. Okay, the leading coefficient down n and 1. Okay. Now let me talk about a special case that you may see in here. So, we see this. F of x is equal to 2x plus 3. This is a polynomial of degree 1, right? So what if I don't have any x? We have like f of x equal to 3 only. And I claim this is actually also a polynomial, but the degree is not 1 anymore. This is a degree, you can guess, a degree 0. Okay? Like, think of this x of 0 here, if that makes any sense here. Okay? But usually people just write 3. This is degree 0. Okay? The leading coefficient is 3, of course. And even more special than this, we have, say, what if f of x equal to 0? Oh, by the way, if this function, if you graph, you're going to have a horizontal line, okay? This is also a horizontal line. The difference between this function and this function is what? Is 0, right? By our definition, all the leading term needs to be non-zero. So this is the only case where the leading term is 0. Actually, this is the only term for the polynomial. And if you have this polynomial, a constant, when f of x equal to 0, very specific, then we say that this is a polynomial of degree undefined, no degree undefined. Some books say this is degree negative infinity, or some book even define this is a degree negative 1, so it make it easier for me to do the algebra, do the math. But our book called it like degree 0. I'm sorry, degree 0 is right. Degree undefined, or no degree. That's the polynomial with no degree. This is polynomial degree undefined. Okay. As I say in here, you read more books. Some author gonna define this one a polynomial degree negative infinity or degree negative 1. Depends. But anyway, this is a very special case. Okay, this is the definition. Let me move on to the next item. I'm going to show you some basic, very basic properties of polynomial functions. Okay, number 2. Properties. The first property we're going to talk about, I'm going to show you the graphs. So basically, a graph of a polynomial function depends on 2 things: the leading coefficient and the degree. Okay, so by looking at the leading coefficients and the degrees, at least you can roughly tell how the graph is going to behave. So let me make a table so you guys can see it. Leading coefficient and the degree. Okay. So we have 2 types of degree. Could be even or could be odd degree. Leading coefficient could be positive or negative. Okay. And if you have a polynomial with even degree and positive leading coefficient, I claim in general, your graph is going to look like this. Both ending behavior going to be going up. And for negative leading coefficients to even, just simply flip it upside down. It's going to look like this. Okay? Positive and odd is kind of going up from left to right. Graph is going to be like this. And then, of course, for negative and odd, it's going to flip over, so it's going to be like this. Okay. You can check it out. The example. Say f of x equal to 3x squared minus 4x plus 1. You guys know everything about this quadratic function, parabola. Okay, graph of parabola. And if you think of it as a polynomial, this is a polynomial of degree 2 with leading coefficient 3. Degree 2 even. 3 positive. See what? The graph is like this. See? So the thing is, polynomial may have high degrees, so this may be wiggling a little, a lot in the middle, but the ending behavior is going to look like this, both up in this case. You see? Okay. And what if I put a negative sign in front? Now, in this case, the graph is flipped over. Okay. What about this? of x equal to 2x minus 1. Leading coefficient 2, degree 1. This is a line going up. This case right here, degree 1 is not in the change direction in the middle, straight up. Okay. And of course, if I put a negative sign in here and negative slope, the graph will be like this. Okay. On higher degree, say I have this. F of x, say equal to, say, x cubed minus 4x. This is a polynomial of degree 3. The leading coefficient is 1. Oh, by the way, only the leading coefficient needs to be non-zero, okay? The other coefficient could be 0. So this one you can think of as what? 1x cubed plus 0x squared minus 4x plus 0. Okay, so the coefficients are 1, 0, negative 4, and 0. And that's makes sense perfectly. But usually in short people are going to write it that way. Just x cubed minus 4x because the 0 turns to 0. Alright? So let me erase this. And if you guys graph this one, you guys are going to see something like this. The leading coefficient is 1. 1 is positive degrees r. 3. So the graph needs to be like this. Match up with this one right here. Okay. So I'm not telling you that you'll be able to figure out the exact graph of polynomial right away, but because I don't know the degree of it, okay? It's different degree, and you have to graph it carefully. But in general, if you only look at two things, the degree and the leading coefficient, at least you can tell the ending behavior or roughly the graph how it's going to look like. Okay. Now, let me talk about another property. Property number 2. I'm going to talk about 3 things at once. Zeros, linear factors, and I'll talk about the x-intercept. Reason why we bring all 3 items at once because they are equivalent to each other in some sense. Okay, so let me start this with an example. Let's start with some easy one. Example: f of x equal to x squared minus 4x plus 3. And this is a polynomial of degree 2 with leading coefficient 1. The nickname of this is what? Quadratic function. Okay, in general, because it's polynomial of degree 2. Usually people call it the quadratic function. Okay, now let's get in here. What if I want to factor this out? What do we have? X minus 1 times x minus 3. Okay. So we talk about 0 polynomial means what? We talk about the value of x, is that when we plug in, we have a 0 come out. Try to plug in x equal to 1. See what we have? X equal to 1. Then f of 1 is equal to 1 squared minus 4 times 1 plus 3. So 1 minus 4 plus 3 is equal to 0. Well, you can even plug it here, right? What? 1 minus 1 times 1 minus 3, either way, is still equal to 0. So you say that x equal to 1 is 0 the polynomial, because when you plug an x equal to 1, you have 0 come out. So the 0 polynomial is the input f that gives you 0 for the output. Okay. Similarly, you got x equal to 3. You got f of 3 is equal to 3 squared minus 4 times 3 plus 3. 3 squared is 9 minus 12 plus 3 is still equal to 0. Or you can plug in here and you got what? 3 minus 1 times 3 minus 3 is still equal to 0. Okay? So what we say in here? X equal to 1 and x equal to 3 are the zeros of the function f of x. That means what? When you plug in x equal to 1, f of 1 be equal to 0. Plug in x equal to 3, you still have 0 come out. Okay. So we talked about the first item, zeros. And you see what it means, right? 0 of a polynomial is the value of the input x. When you plug in, you get 0 come out for the y. Okay. What about linear factor and how they are related? You see the linear means what? Like linear function, right? A factor. You see a quadratic function right here, you can factor as x minus 1 and x minus 3. Those are called the linear factors because the factor with just an x in there is linear. Okay, or graph is a line. Okay. And you see what? Whenever you have a linear factor x minus 3, you know that x equal to 3 is going to be a 0, because when you plug in x equal to 3 right here, you got what? 3 times minus 3 equals 0 times whatever, 0. You have a factor of x minus 1, then you know what? The 0 will be 1, because what? 1 minus 1 is 0, right? So if you have a polynomial factor like this, x plus 2 times x minus 5, then this linear factor is, right, about another one, x plus 4. This linear factor tell you what? You have a 0 of x equal to negative 2. This one you have a 0 of x equal to 5. This one what? X equal to negative 4. That's a 0, right? So this one is a polynomial of degree 3 because it's got 3 linear factors. And you have 3 zeros of negative 2, 5, and negative 4. Okay? So whenever you have a zeros, you will know it's going to have a factor. X equal to 1 is 0, so x minus 1 will be a factor. X equal to 3 is a 0, then x minus 3 are a factor. So what? X minus 1 and x minus 3 are factors, or linear factors of f of x. Okay? So if you know the linear factor, you know the zeros, and vice versa. You know the zeros, you know the factor. So later on, you don't know the polynomial at all, but you know what? X equal to 5 as a 0 is a 0. Then you know what? X minus 5 will be a factor. Is a factor. A linear factor. Okay? I'll just write short factor. So you know of a factor, you know the 0. You know 0, you know the factor. That's why I put them together. What about the x-intercept? Remember what we do to find the x-intercept? You plug in the value. You plug in value for y equal to 0. You solve for x, right? Look in here. When x equal to 1, y equals 0, right? So this is really the x-intercept, right? X is 1, y is 0. Similarly, when x is 3, y is 0. It's another x-intercept. So linear factors right here, and you know that 1 comma 0 is another x-intercept, and what? 3 comma 0 is another x-intercept. So our x-intercept on the graph. Now you see that all the 3 items are related to each other. You know the 0, you will know a factor, and you will know the x-intercept. You know the linear factor, you know 0 and x-intercept. You know the x-intercept, you know the factor and the zeros. Okay. Now let me talk about another item in this section. Still on problem number 2 about zeros and factor. We're going to be talking about something called multiplicity. Because the factor may not be one time, could be repeated. So you can have something like this. F of x equal to x minus 2 times x minus 2 times x plus 4, for example. Okay. And this, you see that the factor of x minus 2 repeated twice. Or I can write this way, x minus 2 squared x plus 4. Okay. And in here we have zeros, is what? X equal to 2 and x equal to negative 4. Okay, 0. X equal to zeros. All right, x equal to 2, x equal to negative 4. All right, linear factors. X minus 2, x minus negative 4 is x plus 4, and you see the x-intercept 2, 0, and negative 4, 0. Okay. Now, what is so special about 2 right here? This factor of x minus 2 repeated twice. Okay. So what? We're gonna say it right here. 0 of x equal to 2 with multiplicity 2. Factor of x minus 2 with multiplicity is 2. Okay? Because we don't take a multiplicity with the end in the intercept. It's about the graph, not about function. So you say here what? Not just 2, 0. You say what? X equal to 2 is a 0 with multiplicity 2. Means what? You actually have 2 of x equal to 2. So actually, you know what many books, instead of writing this way, instead of talking about multiplicity like our textbook, they're going to write this way. X equal to 2, x equal to 2, and x equal to -4. They're going to list all 3 zeros, and that's good. There's nothing wrong with that sense. You see that this x equal to 2 repeated twice. And our book choose another way, which is very common. They write x equal to 2 with multiplicity 2, and then x equal to -4. And don't write anything in multiplicity 1. Okay. And the next question is, how does multiplicity affect the function, affect the graph? You have two types of multiplicity, either even multiplicity or odd multiplicity. So if the multiplicity is even multiplicity, if the multiplicity is an even number, and the graph gonna touch the x-axis. So touch, okay, the x-axis. R is gonna cross the x-axis. Let me show you the example right here. This one. And I claim that you graph this one. F of x equals to x minus 2 squared x plus 4. The graph going to look like this. Just roughly sketch it, okay? Use red color. Just like that. We have two x-intercepts. This is at -4. This is at 2. You see that the zeros are -4 and 2. They go 2 or -4. 2 here and -4 there. We have two factors, x minus 2 and x plus 4. Minus 2 with multiplicity 2. Multiplicity 2, even multiplicity. The graph kind of touches, right? It's going down, it touches the x-axis, bounces back. -4, it's crossing, right? It's from down here, it's going to hit the x-axis and then get cross over. X-axis, y-axis. Okay. How about another example? Let's see. Make it a big one. F of x equal to -3 times, make it a big one, okay? Let me see. X minus 2, x plus 3 squared, and then x minus 1 cubed. Okay? So what are the zeros? This is a polynomial, by the way. This is a polynomial of degree, guess what? Degree 6. Why degree 6? Actually, you have 6 linear factors in here, if you can see it. This is the same thing, -3 times x minus 2, x plus 3, x plus 3, x minus 1, 3 times, x minus 1, right? So really multiply them all out, you got x to the 6 at the highest exponent. So this is a polynomial of degree 6. Degree 6. And the leading coefficient, guess what? It's a -3 right here, -3. Okay? What about the zeros? The zeros are x equal to 2, x equal -3, and x equal to 1. Equal to 2 right here. Let's say x minus 2 is a factor. So the 0 is going to be x equal to 2, right? Because 2 minus 2 equal to 0. X equal to 2. With multiplicity 1, because it's only one factor. -3 with multiplicity 2. And then 1 with multiplicity 3. Alright? You can add all the multiplicity together, you can see the degree of polynomial. Okay? Of course, the factors are right there. X minus 2, x plus 3, x plus 3, x minus 1, x minus 1, x minus 1. we have 6 factors. Or you can say what? X minus 2 multiplicity 1, factor x plus 3 with multiplicity 2, and x minus 1 with multiplicity 3. What about the x-intercept? X-intercept. You guys are going to have 3 x-intercept. And they are 2, 0. What else? Negative 3, 0. And the last one is 1, 0. At those intercepts, at those intersections, are they crossing, are they touching the x-axis? Now it depends on the leading coefficient. So the first one